Hello students, our today's topic is use of logarithmic tables. This is our third video based on the topic. In this video, we are going to learn how to read Antilog table. Here is the Antilog table. The very first column of the Antilog table starts from the point 00 and it ends into point 99. The next columns are starts from 0 and ends into 9. The last part of the table, known as a mean difference, it starts from 1 and end into 9. As you can see, student, the pattern of a table for antilog is same as that of the logarithmic table. Now students, before I start explanation of antilog, let's briefly revise log value. Let's consider number 5. To find the log value of the given number, we must know its characteristic plus mantissa. To find the characteristic, let's consider the range of the number. Number 5 is greater than 1 and less than 10. To find the characteristic of the given number, which is greater than 1, formula used is a number of digit minus 1. The given number is of a digit 1. So from 1 minus 1, your characteristic comes out to be 0. Now let's find out the mantissa. In the very first column, you have to observe the 50. The reason to observe 50 is that there is no 5 digit present in the very first column. So you have to observe directly 50 in the very first column. Now observe the value along the fifth row in the 0th column. That value is 0.6990. Now add these two, characteristic and mantissa. You have a log value as 0.6990. Now student, for the explanation of antilog, I am going to use the same log value. Here, let's consider log value 0.6990. As we know that 0 is the characteristic of the given log value and 0.6990 is the mantissa of the given log value. Now let's find out this antilog. While I'm finding the antilog, I just have to consider its mantissa part because only mantissa part is observed from the logarithmic table. Characteristic is not the part of the logarithmic table. So to find the antilog, we need to consider only mantissa part. And that's why now observe the mantissa part is 0.6990. Now in the very first column, you can observe the 0.69. Now you can understand student why the first column is mentioned like 0.51, 0.52, 0.69 and so on. The reason is that you have to consider only the mantissa or decimal part of a log value and not the characteristic part of the log value while you observe the antilog. Now again, along the 69th row, I can observe the value under the 9th column. Now the last digit in the 0.6990, the last digit is 0. As you can observe student, in the last part of the mean difference, there is no 0th column is present. So that you have to just consider the 69 under the 9th column. Now, this value you have to mention like 0.5000. Now, turn back to the characteristic part. So, how to represent the characteristic in the antilog? To represent the characteristic in the antilog, you have to write this characteristic in the power of 10. So, you write it like this 10 raised to 0. And you have to add 1 into that. The reason to add 1 is that while you find the characteristic, you subtract 1 from that. So while finding the characteristic, you count the number of digit, and from those number of digit you subtract 1. So when you find the antilog, you have to give back that 1 to the value, and that's why you have to add 1 into that. So you have the value like a 0.500 into 10 raised to 1, because 10 raised to 0 plus 1 gives you 10 raised to 1. So this value can be written as a 5.000. But as you observe the last value, this is the same value whose log is 0.6990. So from this you can understand, student, the antilog is the reverse part of the log value. So whenever you have any number, you find its log value, you need to find out its antilog value. So antilog value give you the original form of the given number. So just finding the log is not enough for the use of a logarithmic table. You have to find its antilog always. Why? Because antilog gives you the original form of the given number. Uh, so, so students, take one more example. Now here I directly consider the log value. That log value is 1.5849. As you know that 1 is the characteristic and the mantissa part is 0.5849. Now let's find out the antilog of the given log value. I already explained you, student, for finding the antilog value, you have to just consider the mantissa and not characteristic, because only mantissa part is found using the logarithmic table. So this is the actual part from the log table. So while finding the antilog, we have to use only that part. Now, in the very first column, observe point 58. Along the 58 row, observe value under the fourth column and add mean difference along the same row under the 9 column. The value comes out to be 0.3845. Now next, back to the characteristic part. How to represent the characteristic? To represent the characteristic in antilog, you have to represent it in terms of a 10 raised to 1. And whatever the characteristic you have to add into 1. Because while finding the characteristic, in the case of a log value, you subtract 1 from that. So you have to give it back over here, and you have a like 10 raised to 1 plus 1. So this value is 0.3845 into 10 raised to 2. So when I multiply 10 raised to 2, that is 100 to the given number, I have a 38.45. Log value 2.8112. We know, student, 2 is the characteristic of the log value, and mantissa value is 0.8112. Now let's find out its antilog value. To find the antilog value, we have to consider only the mantissa part. Now observe the point 81 in the very first column. Along the 81 row, observe the value under the first column. In that value, add mean difference of the second column along the same 81 row. So you have a value as 0.6474. Now back to the characteristic. Now represent the characteristic in the form of power of 10. So here you have a 10 raised to 2. In that, add 1. I already explained you the reason behind. While you find the characteristic, you subtract 1 from that. So while you find the antilog, you have to give it back to the value, and so that you have to add 1 in the given characteristic value. So you have the value as a 0.6474 into 10 raised to 3. When you multiply 10 raised to 3 to the given number, the value comes out as a 6.47.4. Now the log value is bar 2.1981. You can see, student, over here the characteristic is negative because it is the log value of the number less than 1. Now let's prove it. For that, we have to consider the characteristic as a bar 2 plus mantissa value is a 0.1981. Let's find antilog value. For that, consider the mantissa part. Observe 0.19 in the very first column. Along the 19th row, observe value under the 8th column. Now add the mean difference from the first column along the same row of 81. The value is 0.1578. Now represent the characteristic in the form of power of 10. So here you have a 10 raised to minus 2. Minus 2 is 10 raised to minus 2. The characteristic is bar 2. Bar 2 means minus 2. So 10 raised to minus 2 plus 1. The value is 0.1578 into 10 raised to minus 1. So the final value I can represent as a 0.01578. Now you can observe, student, over here, as the characteristic of the given number is a bar 2, which I already explained to you that whenever you have the log value with the characteristic as a bar value, then those values or those number are less than the 1. So here is the proof that the given number, its original number, comes out as 0.01578. Now students, some work for you. Some numbers are given to you. Find the characteristic of those number, then find out its mantissa, then find its log value, and then go for the antilog value. You will observe that when you find the antilog of the given log values, the number, whatever you initially consider, the same number you will have in the column of antilog table. From this, we understand, student, that the antilog is the reverse process which gives you the original number. Thank you.